Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Your host is Tobias Macey, and today I'm welcoming back Chris Berg to talk about his tireless quest to simplify the lives of data engineers. So, Chris, can you start by introducing yourself?
So my name is Chris Berg. I'm a CEO of a company called DataKitchen in Massachusetts. I have a long history in technology, going back to the 90s. So I worked at companies like NASA and MIT Lab. I spent a lot of time I was doing AI back when it wasn't cool and your machine learning class had only 6 people in it. So I'm that old. And then about 2005, I'd done a bunch of things in software and managing teams. And I thought the best thing to do would do data and analytics. And so I started managing a team, and I thought my kids were young. They were like 8 and 5. And I thought, well, this will be easy. I'm a big software engineer. This data stuff, no problem. And it turned out my life was hell. Things kept breaking. We could never go fast enough. Everyone wanted their own tool. And that was a really good experience. So we spent 8 years doing a lot of work. We eventually sold the company. And then about 11 years ago, we started this company, DataKitchen, to really focus on those sets of problems for data and analytics teams, which are sort of generated from our experience that stuff's breaking left and right. You can never go fast enough. And your customers are just incredibly demanding. And how do you live in that world and sort of not get depressed and somewhat want a therapist?
You mentioned a bit about what Data Kitchen is, some of the story behind how you got into it. What is it about that particular space of trying to address the problems of data engineers that has kept you engaged and focused on that problem for so long? Shouldn't you have solved it by now?
Well, I wake up in the middle of the night and say I should have, right? So, well, this will be an interesting discussion because why isn't it solved, right? Why aren't those problems solved? And I think they really are in some ways getting somewhat better, but also getting worse. And so a lot of people will build data and analytic systems, right? They'll focus on the first day. They'll go into Azure or Amazon. They'll go into GitHub and go, look at all this stuff I can do. And they'll put together something and have some insight for a customer. And that's great. And they'll focus a lot on building new things, but they won't focus on kind of the second or third day, which is I have to run this.
So you mentioned that you ended up starting Data Kitchen because of the problems that you were seeing as a manager for a data team. And you were one of the people who helped to define and popularize the concept of DataOps. And I'm wondering if you can talk to some of the ways that your journey has progressed and where things are getting better, and maybe some of the ways that things have stayed the same and the pressures of the complexities of data have resisted everyone's efforts to move into this bright new future where everything works all the time.
Yeah, I think we did a survey about 2 years ago of 700 data engineers, and it came back where 78% of them were so frustrated they wanted their job to come with a therapist, and over 50% of them were thinking of quitting. And so, why is that, right? When data is great, we have all these tools. Why are people so upset? And I think it comes down to the fact that we're disconnected from our customers. We're not achieving our goals. And from an industry standpoint, we popularize a lot of buzzwords, and I've been part of that, popularizing data ops, but they mutate and they become almost meaningless. So these terms that go out there, I'm not quite sure, but they're like a gas. They sort of expand to fill everything. And so what happens to any term like data ops or data mesh or data observability or data products or data lakehouse, they start off with a fairly precise definition, but then people end them to whatever they're currently doing and saying, I'm doing data mesh, but in fact, what they're just doing is plain old ETL, or I have a data product tool. And well, what is that? Well, it's really a governance platform. And so the pollution of the namespace in data and analytics it makes it hard to get through that. And, we wrote a manifesto, we've written 2 books on data ops. We've tried to stay pure to kind of the two concepts because of what data ops is. And one is that in production, you're running a factory. of data and analytics. And that factory is taking data from one side and passing it through a bunch of tools and giving insight on the other side. And so the ability for you to run a factory with low errors and low bottlenecks, how you do that takes a lot of inspiration from industrial process control and Deming, et cetera. And then the second part is you have a factory that you want to change very quickly because your customers are demanding. And so that takes a lot of the same ideas that came from agile software development, because the change is a software. Terms are not built by engineers, they're distorted by marketers. And so it's hard to make sense of anything nowadays.
Absolutely. On that note of the misappropriation of the term data ops, it seems to have gone through a similar journey to the concept of DevOps that started, I guess it must be close to 15 years ago now, where it started with a very specific use. It then ballooned to mean everything that had to do with running software and has now largely faded into the background to become part of the typical vernacular. Still not used correctly in most cases, but there's less of a argument about the misappropriation of it. And it seems that data ops has gone through a similar cycle of it was introduced, people started using it to mean everything having to do with data quality, data observability, data testing, and now has started to fade a bit more into the background in favor of the latest cycle of hyped up terms. And I'm wondering if you can give your sense of what you see as the state of data ops today, however you want to define that.
Well, I agree with your definition. I think people even use data ops as a moniker for ETL or data transformation or databases, right? It's everything. And I don't agree with that way of thinking. I do think it's proceeded a lot slower than software, the adoption of DevOps. And I think it's really interesting why. So if, when like 20 years ago, one way I would change code in production is I'd literally go on the production machine and change some code. And nobody on my team went, ew, what are you doing? That's gross. Don't do that. Don't change things on production. In fact, it was seen as kind of cool, like, oh, he's a cowboy. And so what hasn't happened yet with data people is they're not saying ew enough. Like, you just change your code in production and you don't know if it works. You don't automate deployment. You don't have testing. You don't have monitoring. You're kind of hoping everything works. And that's unfortunate, because I think as a team, one of the reasons why we're so depressed and so upset is because of these death of a thousand knives. We're not automating enough. We're not testing enough. We're not saying ew to each other enough. And we're sort of accepting that heroism is part of it. Or on some teams, they're the exact opposite. They live in such fear of breaking anything that they've made, they don't want to touch it. And then they have this sort of procedural defensiveness.
So, along with that misappropriation of the concept of data ops, there were a sequence of subsequent trends that came along, notably data observability, data reliability engineering. Those all try to encapsulate at least a portion of the idea of data ops. And I'm wondering how those subsequent trends from when you first started Data Kitchen, first started trying to popularize data ops, wrote the data ops manifesto, how those different cycles of adoption and technical evolutions have influenced the way that you think about the work that you're doing at Data Kitchen.
Actually, quite a bit. And I think, 10 years ago when I was first talking to data ops, I'd go to conferences and bring up Git, and I had to explain version control. And sort of 1 out of 10 people, 1 out of 100 knew what Git was, knew what CI and CD was. The thought of actually coding SQL freaked a lot of people out. And so I think there's some tools that have really helped the world, like the existence of DBT and its integration with Git and its way of writing template SQL. The sort of 600 or $700 million in data observability investment capital and the massive marketing budgets, that's also helped. People have data observability projects now, or data reliability projects. And I also think the fact that more and more tools actually have Git and CI and CD integration. And so I think those things are not as far out as they once were, which is fantastic. And I think they've actually have influenced. And I think in order to answer that question, I'm a technical founder. It took me a while to start a company, but I was intended to do it kind of based on my values, based on always being profitable. So we've run a company that's never had any investment, either our own or not. We've just sort of been quietly bootstrapping. And I think it's really influenced me because I thought sort of maybe 4 years ago, and even before that, that the way this change would happen in the world, that way people would adopt the principles of data ops, would be from the top down. And I went to a conference, a DevOps conference 6 or 7 years ago, the DevOps Enterprise Summit. And there were all these enterprise teams saying, we're adopting Agile, we're adopting DevOps. They were so enthusiastic. They were so into it. And I'm like, okay, this is going to happen. People are going to start to believe these ideas just like they believe DevOps. And it turns out that's not the way change is happening. And unfortunately, the people who run data and analytic teams have like a 18 to 24 month, sometimes 2.5 year life cycle. CDOs, VPs, they're hired, they're fired so quickly. And when you try to have a top-down change like that and your sort of foundation is a mess, it's really hard to make that happen. And so what we've switched to is really focusing on individual contributors and kind of starting over again. And we have we still support talking to CDOs, but we've open sourced a whole bunch of software targeted at a single data engineer, data quality person who is tired of, getting beaten up for having errors in production, or just tired of being able to go too slow and wants to have more satisfaction out of their job. And so it's really influenced how we think because, how does change happen in the world, right? When we started, we had to say, here's the idea, wrote books, videos, talked about it. We had to run a company, but really we've invested, $6 million in software development, which is a lot for a company like ours. And we've completely open sourced it. It's all full featured Apache 2.0. And we're excited about this sort of opportunity to continue to try to push the market forward.
On that note of how to drive change and the turnover cycles of senior leadership in the data space, I think that speaks to as well the fact that companies think, oh, data is going to solve all my problems. We're going to throw a bunch of money at it. We'll become data driven and everything will be great. We'll be profitable. But then they don't factor in the realities of how complicated the data workflow is, the cycles of how long it takes to actually build out the data warehouse and then be able to gain real value from it. I'm actually reading the Bill Inman How to Build the Data Warehouse book recently, which has a lot of useful insight there about, unlike software, you don't start from requirements and build the product. You build the product and then get the requirements and then you go do it again. And I'm wondering if you're seeing some of those same cycles of senior leadership comes in, they make all kinds of promises, they can't deliver in the time frame that they've said, and then they get kicked out, and then the next person comes in and makes different promises.
And those promises are 100% buzzword compliant. They go to the latest Gartner conference, pick up some buzzwords, and then they're going to do these buzzwords, and then their foundation is utterly unreliable. And so I feel sorry for these men and women who are in these roles because they're trying and they're just thinking about it the wrong way. They're thinking about the data and not the processes acting upon data. They're not thinking about their people and process. They're thinking about sort of trend following. And I think we've built a lot of good things. We have a lot of great tools, but we've got to focus on, as I said, the day 2 or 3 problem. We've got to focus on another way to think about it is what data ops means is you've got 2 23-year-old problems and 1 46-year-old problem. So another way to think about this is you hire a 23-year-old on your team, and he or she's got a degree in computer science, really smart. Maybe they've done some data work and as a co-op student, and you bring them in. Can they make a change? Can they make a small change? A line of SQL, a line of Python. And can that get into production in their first week where that they can make that change and they don't have to be babysat by your senior people? Can they make a change with very low risk? And most data teams don't benchmark themselves that way. They'll make a change and maybe you'll hope it works or it works in their box. And if you just think about, you change a column name, what's the ripple effect on that, on all the other tables, on all the reports, on all the models, on all the governance? Can you have a button next to them? And Tobias, I have a son who's 25, and he took a job at Amazon a few years ago as a software engineer, like in their B2B payments place. And he was able to do that. And, I love my son, and I'm sure he's a good engineer, but if you look at his room when he was, when he was 10, or his room when he was 16, which was scary, I wouldn't trust him to make a change. And so where does that trust come from? Well, they built a system next to their 23-year-olds, to help them deploy fast with low risk, next to their 23-year-olds to help them observe the system to make it right. And then finally, the 46-year-old on the team actually has a set of metrics that measure things like error rates and cycle time and customer satisfaction and productivity. And so we've got to focus on that, on not so much on let's build it, but how do we run it? How do we change it? How do we measure our success? And those things, I think, are really the key to gaining back a lot of time, and the key to sort of minimizing the immense amount of waste that happens in data and analytic teams.
I think that note on the customer impact is also interesting in the context of the data space, because I think that for a long time, there wasn't a clear view on who the customer is of the work that you're doing. When you're an operations engineer, you know that your customers are the software engineers who need to be able to run their applications. The software engineers know that their customer is the end user of the application, whether that's internal or external to the organization. On data teams, theoretically, the customer is the CEO, but only if the CEO knows what he's looking at and how to interpret it. And I think that that's another evolution that we've gone through over the past 10 years, is starting to understand more who is the customer of the data that you're producing, particularly as we move into the ideas of data as a product, data contracts, data tests, things like that.
Yeah, yeah. And I think there's one salient thing it doesn't matter 10 years ago, 20 years ago, you don't know what your customer wants. And like, you may be the smartest person in the world, but like, you don't have the whole business or the whole organization in your head. And so the best way to do that is to deliver small bits of value to your customer iteratively. And so to do that, you need to be able to make changes quickly with low risk. To do that, you need to think and interact with your customer directly. And also, you need to develop a sense of trust. And I think what happens with a lot of data teams is you talk to a customer once, you say, okay, I think you want 10 things. And they instantiate that, and however they do that. And then they go off for weeks or months, and they come back and say, here, I built these 10 things. And the customer says, oh, that's great. I only want 3 of those. Really, those 7 I don't really need. And by the way, here's 5 more. And so the waste that happens in building things that aren't right for your customers is huge. And then the waste of keeping things running that aren't used anymore by your customers is huge. And so I'm all about, let's recapture that waste. And if you look at it from a number standpoint, you could argue that 70% of the time is waste in data and analytic teams. In some cases, it's 90% of the time. And so let's recapture that waste. Let's not focus on being able to write SQL faster, because that's only in the 30% of the time. Let's focus on the system that allows you to put SQL into production faster and monitor it, because that's where you're going to recapture all your time.
Another note from what you were saying earlier about the DevOps Enterprise Summit is that DevOps went through a very long cycle. Even now, there are companies in the enterprise who are just starting to adopt those concepts. New things take a long time to percolate through into the enterprise. And I'm wondering what you see as some of the aspects of data ops, the iterative development and deployment of data and data products that are still lacking that enterprise capability, and some of the things that you see as an industry that we need to address to be able to actually make that leap from, hey, we've got all these shiny tools and everybody in startups and small companies is using them, to all of these tools are robust and enterprise ready and will actually drive adoption at large scale.
Yeah, I guess I just have this, and you might disagree with me. I just don't think it's about the tools, whether they're small scale or enterprise scale. I think it's about the system in which you work with those tools. And so I think we need to work on that. And so we've had enough tools. And honestly, and it's fantastic that we've got, a ton of orchestrators out there. They're all really cool. We've got a bunch of SQL templating tools. We've got a bunch of GUI tools to build things. We can now chat to an LLM and get some SQL. We can write Python. There's 50 different ways to take data from one place to put it to another and do some transformation on it. I just don't think that that's, from a problem standpoint, if 70% of your time is waste, even more, you're improving the 30%. That's not where we're going to make gains. Work on where the big problems are. And the big problems are the systems of work that people have and how they actually enable you to make rapid changes in small increments, run systems so you don't have these emergencies and war rooms where everyone on the team's kind of doing this group grope to find out where the problem is because the CEO's upset. And so I think in some ways it's not about the tools, it's about how you work with your team and those tools. And in some ways, it's not about the data, it's more about the processes acting upon data.
Digging more into that, I think that one of the symptoms as well is that all of the tools are built for data engineers, data analysts. They're not built for other people in the business to actually look at them, interact with them in any fashion. There are some tools that are starting to move in that direction of being a hub of collaboration across the organization, which I think helps to enable that use case. And I'm wondering if you can talk to some of the ways that the massive growth over the past 7 years and recent consolidation has influenced the ways that data teams relate to the rest of the organization and the ways that they think about the purpose of the work that they're doing beyond just, hey, isn't this really cool?
Yeah, well, if you actually open up Azure, there's 10, I think now 12 ways to integrate data, change data. And some of them have nice UIs. They're targeted at business users, some of which are more technical, some of which work on only some databases, some of which are open source. And so of those 10 ways, every data and analytics system has this characteristic of where do you put the logic? And so let's say you get a new question from your customer. Can you segment my customer base? I want to look at them this way. One way to do it is actually do it in the chart and graph tool. Another way is to do it in the front end to the chart and graph tool, like an Alteryx. A third way is have analytic engineers do it in the database. A fourth way is to have data engineers do it more on ingest. And so where the logic lives in your system is actually a really interesting question. And so I'm a believer in making things prove that they're worthy. And so from a logic standpoint, the farther you put it down the stack, the more general it is. But you don't know whether that segmentation is worthy or not. You just want to be able to run it. So maybe it should be in the BI tool. Maybe it should be or maybe the analytic engineer should do it. It's a question and a discussion that you have with your customer about how you maximize the amount of learning, and then either take something and push it into something that's a little bit more tested, a little bit more deployable, or maybe not. And so we're in the ideas and service business and in the promoting people to make quick changes. And then once it's proved worthy, having a discussion about how we can industrialize this, how we can make it safe, how we can eat the technical debt that we may have created, because not everything is worth testing and automating, because it may not. So I think it's really about that discussion and taking things like technical debt and testing and observability and deployment and Git and all those things and putting it on the table with your customer and saying, look, I want to put this on the table as what we do, as well as doing new things. And if you spend my time telling my team all to build new things, we're going to build up so much technical debt and so many problems that guess what's going to happen? People are going to start to quit. We're going to start to go slower. Everyone's going to get frustrated, and you're going to get frustrated. And so to me, it's really about having a good relationship with your customer and a discussion and making some things that are invisible, like testing and automating and deploying, visible to your customer and where things live in the stack. And that's a management technique that I think, we all need to learn. I certainly learned it, and it's just hard because your customers don't really care kind of, where you are. They don't really care about how things work.
Data lakes are notoriously complex. For data engineers who battle to build and scale high-quality data workflows on the data lake, Starburst is an end-to-end data lakehouse platform built on Trino, the query engine Apache Iceberg was designed for. Starburst has complete support for all table formats, including Apache Iceberg, Hive, and Delta Lake. And Starburst is trusted by teams of all sizes, including Comcast and DoorDash. Want to see Starburst in action? Go to dataengineeringpodcast.com/starburst today and get $500 in credits to try Starburst Galaxy, the easiest and fastest way to get started using Trino. Another aspect of this space that I think acts as a distraction is that with every new breakthrough or every new capability, there's another hype cycle of, hey, look at the shiny new tool. It's going to make you move faster and everything will be easier. Obviously, the latest one is large language models and the ways that they can be used to generate anything that you want. And as somebody who has been in the space for a while, I'm curious if you can maybe put this LLM and generative AI hype cycle in the context of other hype cycles that you've seen and some of the ways that you see it as maybe being beneficial and some of the risks that come along with it.
I think it's beneficial. I just don't think it's revolutionary. I mean, so in 1990, I learned to program at NASA with man pages and a bunch of C programs of other people. And then I would go, if I didn't know it, I'd go to this thing called a nerd bookstore that had all, which is now extinct, that had all books. And there used to be Quantum Books in Cambridge and SoftPro. There was a one in the West Coast. And then, it came along in the 2000s and people started to use Google search, right? And people started to post answers to questions on the internet. And what happened is a whole bunch of new people became enabled to be programmed. You didn't have to be like a master's degree dude at NASA to figure it out. And I think what LLMs are going to do are just going to enable another realm of people to start programming more. And I think that's a good thing. But with anything, with any kind of technical activity, it's complexity. And how do you manage that complexity? Especially when you have more people creating it. And then you end up with this question, is it worthy to be tested and observed? Where in the stack should it fit? Maybe we should throw it out. How do we generalize it? What's the right schema? These technical debt questions that we need to continue to work on. And we've got to stop building systems where you're rushing to get stuff in your customers' hands, and then you have no idea if it's going to work the second day and no ability to change it the third.
So moving now into the tools that you were mentioning earlier, you recently open sourced a pair of utilities, DataOps TestGen and DataOps Observability. I'm wondering if you can talk to the specific outcomes that you're trying to drive with those projects and the motivation for releasing them as open source.
I guess the number one motivation is that I've talked to hundreds, thousands of companies over the years, and they build systems and they're having errors in production and their customers are finding problems. And so their customer may be an analyst team, it may be the CEO, but there's customer visible problems. And then they have to react. So they're reactive to customer problems. So our hope in this is that we can make them find problems before their customers see them. And there's two technical challenges that we built this on. Number one is that you have to find problems in data. And so finding problems in data means you have to check the data. And so how do you check the data? Well, you might want to row count and look at anomalies over time. Well, that makes sense. But you also want to actually dig into the syntax of the data itself. And so our TestGen tool profiles your data and then has a sort of algorithmic AI engine that builds a whole set of data quality validation rules for you, so you don't have to build them, and then exposes them through a nice UI, through a YAML file, so you can manage them. So the problem that we're trying to solve with DataOps TestGen is automatic creation of a whole wide variety of data quality rules, because data engineers either don't have the business context to understand what they are, or they don't have the time. And so the reason we open source the second tool, Observability, is that we think the problems in production are not just with data. You can have perfect data and still have a problem, a customer visible problem. You can have perfect raw data and perfect integrated data, but the model may not be right, or the export to the UI, or your reverse ETL may break. So you need something that sits on top of it, and we call that a data journey. And think of it as the fire alarm control panel for your data and analytic systems. It tries to point you saying, hey, the fire's in this room in this corner. And we think that concept of a data journey is missing from data and analytic systems. It's certainly missing if you want to regress a system. It's certainly missing in production. So the two really reasons we built these is, hey, testing data is complicated. You don't have time, so you need a tool to help you generate tests. And then observing the entire complexity of production during production is something that you need to do. And we have this concept of a data journey that we've done. And both are available, both are Apache 2.0, both are completely full featured. And so the outcome that we're trying to do is just use these tools and don't, say when you have a problem in production, start saying, ooh, let's not have that. Let's try to find the way to fix it so that never happens again. And I think these things can accelerate. And we put a lot of work into making them sort of easy to install, easy to use. And we've been working on, TestGen my team and I've been doing data testing for close to 20 years. And so we've got a whole bunch of best practice baked into it. And so really excited. We've only open sourced it like 3 months ago. So it's still quite new.
The observability piece in particular, there are a number of tools that try to address at least a portion of that scope. And I'm wondering if you can talk to the ways that you see your DataOps observability and DataOps TestGen tools overlapping with other capabilities in the ecosystem, and some of the ways that they are differentiated either because of their ease of use or their capabilities, and just some of the ways that you think about their position in the market.
Yeah. And so, first of all, I think whatever you do, it's not acceptable to hope that your production system works. And you need to test data and everything that's acting upon data from a principle standpoint. And then you need to pinpoint where the problem is quickly. And so those kinds of outcomes, I think, are really good. And if you've got, so the person who's listening to this is add some tests yourself, write some SQL tests, just do it. Don't wait for permission. Just start putting tests in. You don't need a tool to do this. And every time you have a problem, try to find a way to automate it or test it so it never happens again. Those kinds of ideas you don't need to compete with someone. And so I think the market itself is for data observability tools is very focused on ingest teams and kind of polling databases for changes. And I think that's a good place to start for some teams, right? Proving that the ingest is right. But there's other use cases in data and analytics beyond that. And we do that. We pull databases, we'll find anomalies in databases. That's fine. But I think you need to look at the full production cycle of data and analytics and test not just raw data, but integrated data. You actually need to test data before you even put it into production. You need to profile data. You need to say, is this data even worthy of being in production? Should you just push back on your data engineers or patch it up before it gets in production? So we have a sort of a more broader scope of how people do observability. But to me, I think start checking and testing your data manually, start looking at products. And I think what all the data observability vendors, I think we all agree on, it's just utterly unacceptable to have embarrassing errors under your customer, in front of your customer. And you don't have to live with it. It's not a good way. You're not a hero. You're just putting a bunch of waste in the system that's making everyone's lives crappy.
So for teams who are looking to adopt these tools, integrate them into their workflow, I'm wondering if you can give an overview about how to actually get them set up and some of the ways that the TestGen and observability tool are going to be interacted with throughout a typical workday.
Yeah. So it's just, you go to GitHub and, we have an installer program. It takes about 10 minutes to install on your machine. And so let's say the first thing you have is I've got a new file that I need to put into my data and analytics system. Well, TestGen will profile it, and then it'll give you a bunch of data hygiene checks on it to say, well, this column's blank. Maybe did you mean to have that? Or you've got 5 different ways to say the same thing. And these are kind of heuristic rules to help you say, maybe this data isn't good enough. And then as you get something in production, we can start polling the database, TestGen and Observability, to find out if things are wrong. And then as your data moves through its other tools like models, visualization tools, export, reverse ETL tools, we have integrations to monitor its progress and to check it if it's right. And so the full data journey as it moves from kind of source to destination, we're checking on. And so all these tools, if you look at where problems are in data and analytic projects and kind of think of them like a graph, oftentimes problems start with bad raw data. But then over time, once you work with your supplier, once you patch up the data doesn't have problems, but also its interaction with other data sets. And you start to learn more about the problems. And then as it goes into production, the problem isn't the data. The problem is someone changed some code acting upon data and your system's not right. And then you need to start thinking about regression and other testing. And so I think where problems lie in your data and analytic team or data and analytic systems often change with the maturity of your system and the maturity of the data set and how complex it is.
What are some of the most interesting or innovative or unexpected ways that you're seeing the observability and TestGen utilities applied?
Well, we have one organization who, they use Databricks. They did all their ETL in its sort of product analytics, so manufacturing product analytics. And so they have all these sort of stream of notebooks that does all this work, all this algorithms, and they had no idea if it ran. It had its own complex interactions. And so they just send a huge amount of data to our system. And it's really, observability is really an API that come from those notebooks. So they're able to find problems in this complex system in notebooks that they went ahead, again, spent day one building a lot of, and are able to find it. And it was a very fast and easy case to do it. Another case is we just have a customer who has sort of, I think, in the order of 80 data sets that are updated often hourly. And they're just very important, very high value. And what they were able to do was instrument the whole system of tests by just sort of scanning it. So they got a big step up on data quality validation testing because they sort of pointed TestGen at it and it automatically generated tests. Now, as time went on, they had to write tests that were sort of specific to their business domain, tests that looked across other tables, tests that compared with history, tests that were very specific. And so they could instantiate those in TestGen. In fact, they wrote some of them themselves and they ran them their own way. And so we're very open in integrating data quality tests that are from other tools. And so really it comes down to, you can build it in whatever tool, but we can capture and observe it, and we can actually generate data quality tests quickly.
Once teams adopt these tools and they have better visibility into their end-to-end flow, how are you seeing that impact the way that they think about building new systems and some of the ways that that drives more of that organizational change?
It lowers the fear. It lowers the shame that happens in organizations. And a lot of teams, they're sort of fear and shame bound. And that locks them up from making changes. And so it just becomes lighter and you enjoy your work more. And I found that personally, like, I had to take, back in 2005, I had to take my team through this, and I didn't know it. I was reading Deming at the time and thinking about manufacturing, but Deming had this thing called a quality circle where you sat around and said, well, what were our problems? Let's put them in a spreadsheet. How can we find the root cause? How can we fix it so it never happens again? And I think teams are lighter, they're happier, they're more able to make changes, they're more able to create, they're not wasting so much time. And it's still early in the release of these tools, so I don't have 100 cases, but I do have the case where people have done with our automation tool. We've seen that a lot of times to be able to make these things. And to me, that's why I'm still doing this. Is it just, my life sucks. I see teams that are just really unhappy, and it's not about your tools. And it's not going to get any better with whatever AI enabled super Gartner buzzword tool. It's just not going to change until you start thinking in systems and thinking in how you actually make your life better.
In your journey of trying to drive the adoption of data ops and the principles that go along with it, and drive this organizational shift to make the data work more impactful, less wasteful? What are some of the most interesting or unexpected or challenging lessons that you've learned in that journey?
Well, first of all, I think I suck at it, because if you would ask me 10 years ago, I thought it would all be done by now, right? I thought at the most, data and analytic teams are 5 years behind. And so it's a lot slower than I thought. And I'm not sure, how, our latest swing at the bat is to go away from leaders and to go to individual contributors. We spent a lot of years building a tool that sort of encapsulated the entire value stream of data and analytics. It was an orchestration, test enhanced orchestrator to try and move things into production quickly. And it was really hard to get that to make money with it, honestly, because people would go ahead and build a whole bunch of stuff. And we had to catch them right at the beginning of their projects. And so for me, and I don't know, I ask you, Tobias, it's slower than I thought. And am I being negative? Am I being too hopeful? Do you think it's never going to be solved? Do you think what do you think of the whole idea of data ops and its maturity and impediments? What's your stand on it?
I think that we have come a long way. I think that DevOps took a decade before it even reached any modicum of widespread adoption. And as you noted, it still hasn't made its way through everywhere. I think that from a tooling perspective and an industry perspective, there has been a lot more focus on making sure that the data that we build and deliver is actually reliable and trustworthy, and that we have a way of being able to actually test changes before they make their way into production and to end users. I think that there are a lot of different players in the space, and so it makes it hard to get everybody aligned. It makes it hard for everything to integrate effectively, to be able to actually make sure that your testing environment is actually able to be run end to end, because there are certain point solutions of, okay, my warehouse can have zero copy tables and I can make some changes to that without impacting production, but can I do the same thing with my business intelligence environment? And just some of the ways that that end-to-end integration can hamper the testing and validation of the changes that you're making before you pull the trigger and say, okay, put all of this into production all at once.
Yeah, yeah, yeah. I think there is a lot of progress, and I think more and more people are seeing it, and I'm talking to teams that are sort of agility is sort of expected now, and not. But of course, I talk to other teams where it's rare, and it's very interesting that you would think it's not the usual suspects, right? The sort of small companies who are unagile, they're big companies who are agile. It's just very interesting, the layout. And from my standpoint, I think the other challenging thing, and this is from a corporate standpoint, or our company, I'm just really grateful I have that we've never gotten investors, that we've always been profitable, because like getting investors would have given us a timeline. And like I never really trusted my ability to predict the future. Certainly with human adoption of ideas, I always thought I would like get it wrong. And so building a profitable company, investing in our employees, making our customers satisfied, and not having to like make these, you know, timelines that I'm not sure if I could keep, I think are good, because we're going to still be here. We're still profitable. We're still going to be around. Hopefully a decade from now, I'll still be talking to you, Tobias, in 10 years, and I'll probably still be talking about the same thing, but hopefully it'll be a lot better.
Yeah. I think another element of this too is that we talk about this idea of data teams who are doing their work, but I think a lot of it too is that you have a company, they start with a software team, they start to realize, oh, we need to be able to do these longitudinal analytics. So they just say to the software team, hey, go build me something. And despite the fact that it's all still software that you're working with, there is a lot more dimensionality to data problems, and there is still a generalized lack of understanding of how that changes the way that you have to think about the problem space. And I think that there just aren't enough people in the ecosystem who have that context to be able to make that a widespread availability of understanding how to tackle the problem properly beyond just I write some software and I put it into production and oh now I've got to go back and keep fixing things because they don't understand it from a holistic perspective.
Yeah, yeah. And I guess the change I'm seeking is that individual contributors who are making that change and going back and fixing it aren't going to passively quit, right? They're going to say, no, we can actually fix this. Here's the steps. And they're going to start to talk to their manager and get their manager bought into it. Because I think I saw that with Agile adoption. There were individual contributors who said, look, I don't want to spend 6 months building something and then no one does this. Can we actually build something in 2 weeks? We're going to learn a lot more. And I think what it comes down to is it's just going to your life's going to be better and you're going to have a lot more fun in your job if you can iterate quicker, you can run things with low errors, you can measure your work. And I think those things have to come from individual contributors because your bosses are just, they got a shotgun to their head and they're getting shot every 18 months. And so it's unfortunate, but it's got to come from the bottom. And I think it's a real opportunity for people new to their career. Because one of the things that makes me sad is people who've gone to school, they've got a master's degree, they came of age when, data scientist was the sexiest job in the world. And then they're just like, they're depressed. They don't like their job. They're like, why am I stuck fixing and refixing things? Why am I not doing anything innovative? And that's just, I'd like that to change. But I think collectively, we've got to start sort of holding our teams to higher standards and how we work together.
As you continue to build and invest in the tools that we discussed and your overall mission at Data Kitchen, what are some of the things you have planned for the near to medium term or any particular projects or problem areas you're excited to dig into?
Well, I'm excited to dig into the role of a data quality person on a data team because I think they've been underinvested on. And I think data observability is very focused on the ingest team and making sure the ingest is good. But the data quality person is really interesting. And we're actually doing some market research now, to talk to a bunch of different data quality people because it impacts, having good data, but also having their ability to influence the team. And so I think we're going to look at that. And then I think one of my favorite things that I hope we're going to get to probably won't be this year, but I think the ability to capture analytics about your data and analytic team, their amount of the amount of work they're doing, the amount of deploys they make, the amount of errors they make in production, their customer sat, like sort of looking at the value streams that people create in production and deployment with their customers. It's amazing how many data and analytic teams don't metric themselves. And they produce metrics, they produce numbers, but they kind of don't know what's going on with their team from a numeric standpoint. And I think we spent our first product solving the 23-year-old deployment problem. Now our second and third products were solving the 23-year-old monitoring and making sure there's low errors in production. And I think hopefully our last product will be solving the 46-year-old problem. How do you run your team in an analytic way? And so those are the things that we're thinking about.
I think that is noteworthy too, because in that concept of the parallel between DevOps and DataOps is the concept of being on call, error monitoring, trying to drive down mean time to resolution, mean time to detect failures. I think that is one of the pieces of the data ecosystem that is still in the process of being figured out of what does it even mean for a data person to be on call and what does it mean for there to be an incident in the data platform.
Yeah, yeah. And what is it? And is it number of incidents? What's the impact? And I think it's important to measure those things because if you look at it from a manufacturing line, your error rates and how you manufacture and bottlenecks are huge impediments to success. And so, like, you don't need fancy software to do it. Like, I encourage every team to get a spreadsheet, and every time you have any production error, put it down in that spreadsheet. And then just every 2 weeks, sit with your team and say, what's the one thing we can do to automate this so it never happens again? What's the script? What's the test? What's the fix we can do? And so I think that sort of being able to reflect and think of it as love your errors. Try to have a way where errors aren't cause you sort of shame and blame, but let's love them and try and fix them and improve them. And I think that will help your team be more productive and get better. And you don't have to do any software to do that. You just have to have a spreadsheet.
Are there any other aspects of this overall ecosystem of DataOps, the work that you're doing at DataKitchen, the specifics of the observability and TestGen tools that we didn't discuss yet that you'd like to cover before we close out the show?
No, I may sound negative, right? Like people are depressed, they want to quit. It's frustrating, but I think in this change, and I think the fact that like we've had this great burst of tool creativity, and the fact that we're seeing some consolidation, and I think is actually a really opportunity for people to reflect on how they do work and improve it. And I think there's so many new people, and they're running into the same similar sets of problems that I'm excited at the future. And I think it's really going to be a good thing when you don't have to have these huge data and analytic teams, where you could have a smaller one that's that does more work and does better work, and the teams are happier and people aren't quitting. And I'm looking forward to helping sort of nudge that along in the future.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, I think it's that last one. I think it's the 46-year-old problem of how do you measure the success of your data and analytic team. I think both definitionally, what is a successful team look like? What are the numbers? In software, there's DORA metrics, DevOps Research Association. They have sort of a set of metrics that are really sort of software deployment focused. I think those, and we have a set of deployment metrics. We have a set of production error metrics. We have productivity, customer sat. I think the biggest gap is really measurement of our team and what those measurements are. And I've often thought we need a DORA group for data and analytics. What's the common way to benchmark teams in terms of how well they're doing, how successful they are, and what things that we should measure? And so that's another challenge I think. So I think some smart entrepreneur will pick up, or someone should work on.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing on the observability and TestGen tools, your perspective on the evolution of DataOps and its adoption, and the ways that we are trending as an industry. So I appreciate the insights and the time, and I hope you enjoy the rest of your day.
All right. Thank you.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.